When LLM says something like, refunds are processed within 30 days, we can't just take its word for it. We need a proof. Which document said that, which paragraph even, and if the support agent is going to trust the answer, they should be able to see the exact sentence it came from. That's the whole idea behind citation, a verifiable thread running backwards from the answer to the source that actually said it. This episode is where we build that thread. It is the generation stage. By the time we are done, every answer the system produces will carry validated citation pointing straight at the policy of the frequently asked questions that supports each claim. But before we walk through any code, let's jump straight to the payoff. Our knowledge base is already stocked with chunks pulled from the sample frequently asked questions and policy files we ingested back in episode 2. So there is no reason to keep you waiting, and let's ask a real support question. There is a money shot, an answer paired with the citation pulled straight from the policy.md. Now let's raise the stakes a little bit and try the frequently asked question. Same pattern, answer plus citation, with time pulled from the frequently asked instead of the policy doc. But now for the real test, what happened when we ask something outside of the knowledge base? Perfect. The LLM does exactly what it should. It doesn't panic, doesn't guess, doesn't make something up. It returns the fixed no-info response along with the empty citation array. The contract matters more than it might seem. When the knowledge base generally has nothing useful to offer, the system says so plainly instead of inventing an answer out of the thin air. And if the LLM ever tries to sneak in a fabricated quote, the validator catches it and drops it, and hallucinated citation simply never makes into the response you see. Let's walk through how it works now. Generation starts with the prompt. That's where all of this comes together. Open generation prompt.py. Right at the top sits system prompt, the instruction block that hands the LLM its role and its security rules in one shot. It tells the model plainly that it is a support knowledge assistant and that it is only allowed to answer using the context chunks it's been given, nothing from memory, nothing improvised. The security section goes a step further. It declares that the system message always outranks anything found in the user query or the context. So, if some mischievous frequently asked question entry tries to whisper something like ignore previous instructions, the LLM just shrugs it off as reference text, not a command for obeying. We also tell the model exactly what to do when the context comes up short. Respond with the fixed string. I do not have relevant information in the knowledge base to answer this question, and return an empty citation array. Next, format context chunks function takes the retrieved chunks and dresses them up for the LLM to read. Each one gets a little header up front, its chunks ID, the source file name, and the chunk index, followed by the actual chunk text. To keep things tidy, we separate the chunks with the triple dash lines so the LLM sees clear boundaries. Build messages assembles the final prompt, stitching everything together. It calls format context chunks to get the formatted context, then tucks it inside the context tag in the user message, while the actual query lands inside the user query tags. Those XML style markers aren't just decoration. They give the LLM a clear way to tell reference material apart from a real question being asked. Near the end of the user message, we spell out the JSON schema. The response has to follow an answer string plus the citation array, where each entry carries a chunk ID, a source, and a quote. The quote field isn't the paraphrase. It has to be the exact substring lifted straight from the chunk text. That comes back from this function is a list of two messages, the system message first, and then the user message with the context and query. Now we call the LLM, the moment everything's being building toward. Open generation generator.py. The generate answer function takes the user's query and the retrieved chunks, builds the prompt with build message function, and fires it off to an OpenAI API. They spin up the OpenAI client using the API key pulled from the setting, which itself comes from the .env file. The chat completions create call reaches for the model name and settings, which is GPT-4 mini by default in our situation, and we pass response format, which is JSON mode. It forces the LLM to hand back valid JSON instead of loose conversational text. We also pin temperature to 0, which makes the output more deterministic. Feed it the same query with the same chunks and you will get the same answer every time. We will need it because it is essential for testing and for caching, which is coming in a future episode. Now we parse it with the parse LLM JSON function, which is the small helper that does the unglamorous work of tuning the raw text into something usable. It runs JSON loads on the response content, pulls out the answer field, fading back to an empty string if it is missing, and loops through the citations array. For each citation, it grabs the chunk ID source and quote fields, checks that they are all non-empty strings, and packages them into the raw citation data class, which is the plain little container with the free fields, whose only job is to keep LLM output parsing separate from the validation logic we are about to see. Anything malformed, like the citation missing its chunk ID or some stray non-dict item in the array, just gets skipped. What comes out the other end is the answer string and the list of raw citations. After parsing, we call validate citations, handing it the answer, the raw citations, and retrieved chunks. This function goes through gatekeeping, checking every single citation against the actual chunk text it claims to come from. And only the ones that survive that checks make it into the final response. Let's look at the validation logic. Open generation citation py. The validate citation function starts by building a lookup map from chunk ID to the actual chunk object. Nothing fancy, just a way to check a constant time whether a citation point at the chunk were actually retrieved, when it loops through each raw citation one by one. First question, does the chunk ID even exist in our retrieved set? If not, the citation gets dropped on the spot, the LLM pointing at the chunk we never had. Second question, does the quote actually show up word for word in the chunk text? That's where the function quote in chunk comes in. It normalizes both the quote and the chunk by lowercasing everything and collapsing extra white space, then checks whether the normalized quote sits inside the normalized chunk. That small bit of forgiveness handles the harmless formatting quirks, stray spaces, mismatched capitalization, without rejecting valid quotes. If the full quote doesn't turn up, we don't give up on it right away. We try to salvage what we can by splitting it into sentences. The valid quote spans function breaks the quote apart using a regex tuned to periods, exclamation marks and question marks followed by white spaces, then checks each resulting sentence on its own metrics. Any sentence that does appear in the chunk earns its own separate citation. Anything that doesn't gets quietly dropped. If not a single sentence matches, the whole citation goes. It is a small bit of mercy. Then the LLM blends an accurate quote with the hallucinated phrase. This lets us keep the correct part. One more check. Is noInfoAnswer function looks at the answer text and asks whether it matches the fixed no relevant information string we defined back in the prompt model. If it does, we clear out the citation list entirely, even if the LLM went ahead and hallucinated a few citations away. That guards against the awkward mismatch, the kind where the answer says I don't know while the citation array sits there full of entries as if it doesn't. Under the hood, the function normalizes the answer by trimming white spaces and lowercasing it, then checks for either an exact match or the phrase no relevant information appearing as a substring. Either condition is enough to treat it as a no-info response and clear the citations. After all checks, we are left with a clean list of validation citations, nothing more, nothing less. Each one carries a chunk ID that generally exists in the retrieved set, a source file name, and a quote that's been verified word by word against the chunk text. Anything shaky has already been filtered out. So this is our step the client never sees hallucinated quotes. Now we wire into the API, the part where all this logic finally becomes something callable. Open API roots ask.py. The run ask helper is where the core logic lives. It takes the user's query, their role, and the settings object. Then gets it to work. First, it calls retrieve function from the retrieval pipeline, which runs hybrid search and hands back the top ranked chunks. Then it calls generate answer with the query and those chunks, and finally it wraps everything into the ask response bidentic model, converting each raw citation object into a proper citation model for the JSON response. That conversion happens in a simple list comprehension, looping through the validated citations and building a citation object for each one, carrying its chunk ID, source, and quote fields. The ask question route is the actual HTTP endpoint. It is decorated with the router post ask, so it handles post requests sent to the ask endpoint. The route accepts an ask request body, a bidentic model with the query field, and an optional user role field that defaults to support. Settings get injected through the API dependency system. And the very first thing runs here is enforce or block, which is a security guard function that for now is just a placeholder returning none, because prompt injection detection is coming in future episodes. If it ever does return a response, we send that straight back and skip everything else. Otherwise, we call cached ask with a query and lambda wrapping, which is a run ask. What cached ask returns is the response itself plus some metadata about cache status and latency, which we turn into the custom HTTP headers. Xcache tells you hit or miss. Xlatency MS tells you how long it took, and Xtokens saved will eventually show token saving once caching is live. We finish up by returning the JSON response with the response body and the custom headers. The request and response schemas live in API model SPY. Ask request carries a query field that must be at least one character long, plus a user role field defaulting to support. Citation is simple, 3 fields, chunk ID, source, and quote with the quote field description, spelling out the rule we have been enforced all along. It must be exact substring from the cited chunk text. Ask response rounds things out the query, answer, and the citation array. These models aren't just bookkeeping, they generate the OpenAPI docs automatically and validate incoming requests and outgoing responses. Finally, we register the route inside the API main py. We import ask route from the API routes ask and call API include router with the ask router as a parameter to bolt it in onto the fast API app. That one line is what makes ask endpoint live the moment the server starts, and up at the top the lifespan context manager takes care of running database migrations before any traffic is served, so the chunks table is already sitting there, ready and waiting when the first request comes in. Let us run the tests, the always good moment of truth. The comment is of run pytest test ask py. This file covers the scenarios that actually matters, a question with the relevant context that should come back with the citation, a question with no relevant context that should trigger the no info answer, and a handful of edge cases, like empty citation or malformed output from the LLM. All 7 tests pass, which gives us real confidence that the prompt construction, the LLM call, the citation validation, and the API response are working correctly. The tests validate that answer field never comes back empty when relevant context exists, that every citation carries is required field, that the no info answer shows up exactly when it should, and that any invalid citation gets dropped rather than sneaking through. Those are contracts we will need to keep intact as we peel on more features in upcoming episode. We completed the generation stage, and it is a solid one to have behind us. The ask endpoint now hands back grounded answers with validated citations attached, or when the knowledge base has nothing useful to offer, the fixed no info response instead. JSON mode keeps everything honest by forcing structure output, so every response follows the same shape no matter what. The validator makes sure every single citation point at real chunk backed by the quote that actually been verified. Next episode, we bring the radius caching, so repeat questions can skip the LLM call entirely, saving tokens, saving money, and cutting latency. If you found this video helpful, learned something new, or discovered ways to simplify your workflow, boost your productivity, or even save money, please subscribe my channel and hit the like, because it really helps me to grow and keep digging to discover new things and continue creating more content like this. Also, leave a comment below with your thoughts, questions and experiences. My goal is for us to learn, grow and build real AI expertise together, and your feedback is an important part of that. Thanks for watching and see you in the next videos. Laughing, dance all night.